Hello everyone. Today we will discuss about the problem in electrodynamics, which is the 47th problem. We will consider the RC circuits actually. Okay, let's try to solve the problem. In the problem, it said that in figure, suppose the switch has been closed for time interval sufficiently long for the capacitor to become fully charged. So in the first case, we have to find the steady state current in each resistor, and the B part the charge Q max on the capacitor, and the C the switch is now opened at T0. Write an equation for the current in R2 as a function of time, and the D find the time interval required for the charge on the capacitor to fall to 1/5 its initial value. So let's consider this problem. In the A part, okay, first of all, let's write it's a givens. What the given? We know that the EMF of the circuit is equal to 9 volts, and we have R1, which is the resistor first resistor, equal to here 12 kilo ohm, yeah, kilo ohm. Second resistor equal to 15 kilo ohm. Third resistor is equal to 3 kilo ohm, yeah. 3 kilo ohm. So we have three of them. Then one more thing is the capacitor, which is 10 microfarad, yeah. In general, we will solve the problem by using the Kirchhoff law in the first case, in the A part. Why? Because it said that the steady state current in each resistor. So what does it mean? It means that in this circuit, when the capacitor will be fully charged, we can consider the circuit at the like the current is going through two resistors, and they're coming back to their initial position, yeah. So in the first case we can use like that. First of all, we have to just how can I say, we have to find the total resistance of that circuit. It's equal to R1 plus R2. R total equal to 12 kilo ohm times plus 15 kilo ohm, yeah. We can write two of them. Then R total equal to 27 kilo ohm, yeah. We have total resistor, yeah. So at that case we can find that the current which is going through that circuit are equal to current equal to voltage divided by total resistor. It's equal to 9 divided by 27 times 10 to the power of 3. It means that the kilo, it's the 3 to the power of 3. Current equal to, let's calculate by using the calculator. 9 divided by 27, it gives us 0.333 times 10 to the power minus 3. So we can take current as a 333 microampere. Yeah. So in the A part, we found that the current, which is equal to 333 microampere. So in the second case, in the B part, it said that the charge Qmax on the capacitor. So what does it mean? When the capacitor fully charged, we can fully charge it. So we have to find that Qmax on the capacitor. So what do we need to do? First of all, we need to know that when the resistors in the parallel when how can you say, when they are placed parallel, yeah, we can take the voltages as equal, voltage 1 equal to voltage 2. I mentioned that the voltage on the first line, yeah, equal to voltage of the second line. Yeah, they are equal. Why? Because when we are conducting the resistors in parallel, we can take the voltages as equal. Yeah, they are equal. in that case, we can find that current, that voltages by this formula. Yeah. Current, no, not current, voltage of the first loop. Yeah. First of all, voltage of the first loop equal to, we can take as a current multiplied by R2, and the V1 is equal to, that's 333 microampere times 15 kilo ohm. Yeah, then it's equal to approximately, I think it's a 5. Yeah, just a second. 333 times 15, it's equal to 4,995. Yeah, 95 times the micro, it's the 10 to the power of minus 6, and the kilo, it's the 10 to the power of 3. Yeah, just 3. So we can take that the 10 to the power of minus 3. So it's overall, it's equal to 4.995. So that's approximately 5 voltages. So we found the voltage, the first of the first line of the voltage. We can take for the second voltage at the 5 voltage, because they are equal due to the we conducting the resistors in parallel. So 5 voltages, it's equal to, yeah, we can take that voltage of the second line, it's equal to 5 voltages. So that's, we found the voltage. Then after the finding the voltage, we can find the maximum charge of the capacitor. Q max equal to just capacitor times voltage of the second line. It's equal to 10 to the power of minus 5, because in the beginning we took the 10 to the power of minus 6 times 10, it gives us minus 5. Then times voltage of the second line, it's equal to 5. So we can just take that like that, 50 microcoulomb. That's why. So in the third question, they are asking that the switch is now opened at time 0. In the C part. In in the C part, the switch is now opened at T0. So it meant that T time is given at the when time is equal to 0. Write an equation for the current in R2 as a function of time in the current in R2 as a function of time. So we have to just find the we have to just write the equation for the current. So in the switch, after the opening the switch, we can see that there are just remained that circuit, which is in the left side. In the left side, we have one resistor, which is R2. R2, yeah. Then on the right side, one resistor, and also one capacitor, yeah. In the C part, we just consider that circuit. Why? Because after the opening the switch, the charge remained at the capacitor. That charge will be going through that circuit, because after the opening we don't need to consider that circuit, which is placed on the left side, located on the left side. So it's our second resistor. This is our third resistor. Yeah, that's our third resistor. And then this is our capacitor, which is equal to 10 to the power of 10 microfarad. Now we have to write the equation. Equation depends on the changing of charge, yeah, which is the current that is changing, yeah, depending on the time. So we have to first of all write the minus dq divided by dt. Why? Because our resistor decreasing the flow of current. Due to that, the current is, we have to take them with minus value. Minus dq dt. So after that, we just write an equation with that. Q divided by C, it's our V, voltage. In our closed surface, we know that our sum of the voltages equal to 0, yeah, in the closed surface. We just write an equation for that voltages. Q divided by C, it's our voltage of the capacitor, minus our our voltage of the resistor is equal to IR, yeah, just IR. It's equal to 0. Yeah, this is our sum of the voltages. Let's dive into Q divided by C, it's equal to IR. We know that we opened the current by that formula, which is minus dq divided by dt. Why we take that formula? Because, as I said, by after a few times it will be decreased due to the resistor. It will be given for the heat of the wire. Let's write this equation for that current. D divided by C equal to minus dq over dt times R. After writing that, let's divide them. Let's take C to right side, dq, no, we will just move the resistor to the left side, and the dt also will be moved to the left side. Let's write that. 1 divided by RC times dt is equal to minus 1 divided by Q times dq. So we wrote an equation for the charge. Yeah. Now we will be integrate this equation in the from the both sides. Yeah. On the right and the left sides. In general, we will take the 1 over RC times T equal to minus ln Q. After taking that, we can put the limits for each of them. On the left side, we have to take the limit for the time dependent, because at the beginning it will start from the time 0, then till the t second. Yeah. On the right side, Q will be in the beginning Q max, but in the finally it will be some kind of Q. We know that Q max is given as I shown in the previous part of the problem, and that now we will solve the problem by continue that equation. Let's write just let's put all the givens. There we have Q max. Let's write there Q max equal to 50 microcoulomb. Yeah. Let's write the equation. 1 divided by RC times T. Sorry, I missed the dt because we no, sorry, we took the integral already. In place of t, we can put just t, and on the right side we can just write like minus ln. On the beginning, we can put just q, and on the second part we put the q max minus, and also in the equation we have minus ln. Yeah, actually we just put the q max. After putting the all givens, we took that equation 1 divided by RC times T equal to, if we open the brackets, we can take that ln in the bracket, in the module, we can say that q max divided by q, because of the ln's like capability. So in that case we can find the q Q is equal to, uh, if we uh, multiply to in the both sides to e, like the exponential to the e, Q will be equal to just Q max. Let's first of all put the e. Maybe some people will not understand that. E in the power 1 times RC times T, it's equal to Q max over Q. After that, we can divide, we can replace them for finding the Q max divided by e to the power of 1 divided by RC times T. If we wanted to move this e to the to up, it will be Q equal to Q max times e to the minus in the power minus 1 divided by RC times T. After that, we have the already charge equation, but in the problem it had that write an equation for the current. So after the finding that Q, we will just take derivative depend on the t, like depend on the time, because current is equal to actually dq dt. Yeah? Let's take a derivative from that. First of all, I will take a copy. I will do a copy of them and move to the new page because it is fully actually. Yeah. I will put there my number, my equation actually. Yeah, this is our equation. If we just take derivative from that equation, d divided by dt, depending on the time, we will take that current dq over dt, it's equal to q max times, if we take derivative from the t, this coefficient in the power, it will move in the front side, minus 1 divided by RC times e to the power of minus 1 divided by RC times t. So we can see that dq over dt, it's our current. Actually, it gives us current, and the current equal to q max times minus 1 divided by RC and times e in the power of minus 1 divided by RC times t. And finally, current equal to q max minus q max over RC times e minus in the power of e 1 divided by RCT. Yeah, this is our finally equation for the current. So this is our third part, which is C part. In the finally, they ask that maybe I will copy that photo. Yeah, I copied that photo and put on the new page. Oh, finally, in the D part, they asked find the time interval required for the charge on the capacitor to fall 1/5 its initial value. So, in the beginning, we already found the equation for the charge. It's our Q equal to Q max times e to the power of -1 divided by RCT. Yeah, we will just take that equation for our D part. I will just duplicate it and put here. For it said that the charge on the capacitor to fall to 1/5 its initial value. So that means Q equal to 1 divided by 5 times Q max. Yeah, if we put that given 1 divided by 5 Q max equal to Q max times e to the power of -1 divided by RCT. We can cancel Q max on the both sides. After the canceling that Q maxes, I will just do that. I will do some ln 1 divided by 5 equal to -1 divided by RCT. From here we can find the time, which is our final time, which is gives us that charge. Time equal to ln, I will write that 0.2 times minus RC. That in the finally t equal to ln 0.2, it gives us ln 0.2, it gives us minus 1.6 times our resistor is actually equal to just a second. Our final current, final resistor, like total resistor, is we can take from here. Our resistor in here, I forgot to find the total resistor. We can just take, we can find the total resistor by using that series formula for serial conducting the resistors in series. Resistor 2 times resistor 3. From here we can find the total resistor. It's equal to the given 3 and the 15 kilo ohms. Yeah, 15 and the 3 is it gives us 18 kilo ohms. Let's put that value minus 18 times 10 to the power of 10 to the power of 3 times we already know that the capacitor is equal to 10 to the power of -5. the final is just mathematics. 1.6 times 18 times, yeah, just it gives us 28.8 times 10 to the power of minus 2. These two minuses will be plus. It gives us 0.288 second. So it approximately 0.29 second. So we already solved the all parts of the equation, the all part of the problem. Uh, if you have any question, you can write on the comment. I will read all the comments. Thank you for watching. So if we come to the simulation part, we can see that there we have, yeah, actually 20k kilo ohms and the 15 kilo ohms, and the located to them parallel 3 kilo ohms, and the in series 10 microfarads, yeah, which is the capacitor. Yo, let's see that in the first case, they said that uh, at the steady time, mm, we can consider uh, that after the steady time, after a long time, we can see that after the capacitor fully charged, it will not how can I say, it will not give an access to the current with current flow. We can just consider that small circuit, which is there is considered two resistors with one of them 12 kilo ohm, and the second one is 15 kilo ohm resistors. Yeah, as I said, we will consider that two resistors, we will just conduct them uh, in series, and we will take 27 kilo ohms. Yeah, uh, if we see that here, the ampere is actually equal to 333.333, yeah, milliamperes, microampere. Yeah, we found that value actually. So that means our answer is correct. Yeah. In the second case, uh, they asked how many charge capacitor will uh, uh, gather in their in it. Yeah. Uh, Capacitor shows that 50 microcoulombs, which we found. Uh, yeah, I said that uh, when resistors are located, like how can I say, conducted in parallel circuit, in parallel, we can see that two voltages in the circuit uh, equal to 5 volts. Yeah, yeah, in the right side 5 volts, in the left side it's equal to also 5 volts. So that means in parallel, uh, in parallel the voltages are equal. uh, by using that voltages, we can found the maximum charge of the capacitor is equal to 50 microcoulombs. Yeah, in the third case, we cannot see that because it's the too little time interval. Uh, but we can we can just see that time roughly, but it is it will not be like, how can I say, it will not be visible much more better uh, if we put the reset uh, and our capacitor is already fully charged. Yeah. When I open the key, uh, I open the key and I press the button reset, and I see the time and see the voltage. Here the voltage is decreasing. Actually, yeah. The Due to that, our uh, voltage giving to resistors to heating. Yeah, our resistors are will be resistors heated. So due to that, our charge will be uh, cancelled from here. Yeah. In general, we can see that our circuit is already works. Yeah. Our this mm, our solving problem. It's our solution. Actually, it's right because as I show you here 5 voltages and here 5 voltages, they are equal, as I said, and also after a long time we can see that the second part of the circuit, which is conducted the capacitor and the resistor, they are will be like as a, how can I say, um, as a not needed uh, line because there is no current flow going through there. We can just consider that two resistors, and we will we will mm, plus them, two of them in series because they will be conducted in series. Yeah, and our 9 voltages, which is given in the beginning. Yeah, that just simple. We can see that circuit is working well. Thank you for watching. This is the simulation of the circuit which we are solved.